In this video, we are going to discuss the formation of ions, positive ions and negative ions. Positive ions are called cations, and negative ions are called anions. To make a positive ion, remember that we cannot do anything about the nucleus. All the chemistry happens with electrons, and therefore we can gain or lose electrons, but we are not going to do anything with protons because then those are nuclear reactions, not chemical reactions. Therefore, since we cannot touch the protons, and if we do anything to the protons, we change the atomic number, we change the element. So we will not mess with the protons, but we can change the number of electrons. If an ion or an atom loses an electron, or it can lose more, one or more, we are losing negative charge, which means that the atom is becoming more positive. The number of protons is larger now than the number of electrons. So we have an excess of positive charge. That is a positively charged ion or a cation. The opposite is true for a negatively charged ion or anion. They gain electrons, one or more electrons, and once again an electron brings a negative charge, and now the element has more negative charge than it does positive charge because we didn't change the number of protons, and therefore those extra negative charges are reflected in the type of anion that it forms. There is a way to tell generally what atoms form what type of ions, and let's take a look here. Atoms of the main group elements, so not the middle chunk, the D block elements, those are called transition elements. So we're not talking about those, but we're talking about the main group. So the S block and the P block of the periodic table. They will lose or gain electrons to achieve noble gas configuration, and we mentioned that in previous videos. So all of the other elements in the periodic table are trying to reach that noble gas configuration because those noble gases are very stable. They have full electronic shells, and therefore atoms are going to try to beg, borrow, and steal electrons till they get to that point. Some electrons or some atoms lose electrons to form positive ions. Some atoms gain electrons to form negative ions that are isoelectronic with a noble gas. Isoelectronic means they have the same electron configuration or the same number of electrons as a noble gas. The other types of atoms, and we don't have that in this video here, but other types of atoms will share electrons to get to a noble gas configuration or to get a full octet around it. Because atoms become isoelectronic with a noble gas, this enables us or allows us to predict the number of electrons that can be gained or lost and what type of ion is formed. So if I'm looking at calcium, for example, and I know that calcium is in the row 4, so it is in period 4, and it's in the S block. It just fills the S block. So the previous noble gas before calcium is argon. I can replace all the inner core electrons of calcium with just the configuration of argon. So square brackets, argon, close square brackets, and then what's left over is 4s squared, or 4s2. There are 2 electrons that are left over after the noble gas configuration of calcium. So how does calcium become isoelectronic or have the same electron configuration as the nearest noble gas? So in this case, for calcium, the nearest noble gas is argon. All calcium has to do to become like argon is lose these electrons, these 2 electrons. And if it loses those 2 electrons, it takes the form of argon, square bracket, and we write them, so we write the ions slightly differently than we do the atom to tell them apart. We write the identity of the element, so it's calcium, but note that it's not the atom anymore because it is charged. It lost 2 electrons, so we denote by a superscript on the right-hand side. We write a 2 plus for the charge of calcium. Note that the plus tells us that the atom has lost electrons, and the number in front of that sign tells us how many electrons it has lost. So calcium has lost 2 electrons, and therefore it's a positive ion. If it had gained 2 electrons, it would have a negative sign and the 2 in front of it. Or the negative in front of the 2, it doesn't really matter. Some people like to put +2, some people put 2 plus. It's fine either way. Once again, we look to the periodic table to decide. Note that this middle block here, the D group, the D block, these are called transition elements. I call these the unruly children. They don't really behave the same way as the other elements in the periodic table. So this is the S block and the P block. We'll talk about these more in a little bit, but right now we'll focus on the main group elements, so S block and the P block. To determine how many electrons do they gain or lose, we look to see how close they are to the nearest noble gas. So for calcium, it's over here, and it's closest to argon than it is to krypton. So look at how many electrons does it have to gain to get to krypton. But it needs to lose only 2 to get to argon. Therefore, it's easier for calcium to lose those 2 electrons. This will also play into the periodic trends that we were talking about in the previous video. These elements over here have low ionization energies, which means it doesn't take much for them to lose those electrons. And that's why it's easy for these elements in the S block to lose electrons. These elements over here have high ionization energies. It's very difficult for them to lose electrons, but they have high electron affinities. They can gain electron easier. And why is that? We'll look at where fluorine, for example, is right next to neon, element number 9 and element number 10. To become like neon, all it has to do is gain 1 electron and have 10 electrons, just like neon. 1 more, and so it's easier for it to gain 1 electron than to lose all of these electrons here to get to number 2, which is helium. Same thing with chlorine, right? It's 1 away from argon. It's easier for it to gain that 1 electron than to lose all of these electrons to go down to 10, from 17 electrons to 10 electrons like neon is, and so on and so forth. There is an easy way to use the periodic table to determine kind of what charges each element can have, or what kind of ion it will have, and we go by the number of the group number, ignoring those D block elements over here. So group number 1 will always form a +1 ion, always. So you can write that in your periodic table, and that is fine. Make a note that group 1 elements will form a +1 ion. Group 2 elements will form a +2 ion. When we get to, so skipping the middle chunk, we get to group 3 or 13, depending on the periodic table notation. I like to go by 3, so skip the middle part and go directly to 3 instead of 13, because then that corresponds to that 3 plus, right? Ignore the rest of these. We'll just focus on aluminum on that group 3. It forms a 3 plus. And then this group here, group 4, does not gain or lose. They are those that share electrons. Okay. Then when we go to group 5, note that these are only 3 electrons away from noble gas, which is right here. So group 5 will typically have a 3 minus charge. Group 6 is only 2 electrons away from the noble gas, but they have to gain to get there. So oxygen, sulfur, selenium, they will gain 2 electrons to get to noble gas configuration, so they'll form a 2 minus ion. And the fluorine, the halogen group, as I mentioned in the previous slide, will gain 1 electron, and so they have a -1 charge. In addition, we will focus on these 2 ions. These are part of those D block elements in the middle. And we'll talk about it in a few more videos down the road, but those elements can form multiple types of ions, and that's why they become a little bit more difficult. But out of those elements, I want you to pay attention to zinc and silver. Zinc and silver. These 2 elements will form, zinc will form a 2 plus, and silver will form a +1. And we will consider these as unchanging, that these 2 always form a +2 and a +1 ion. Okay, let's look at the sample problem. Predict the charge on the ion formed from each element that is listed. We will go to the periodic table, right, and figure out where sodium and calcium and oxygen are and what type of ion they will form. Now, we started talking about Lewis dot symbols in previous videos, but we can also write Lewis dot symbols for ions, not just atoms. We start with the Lewis dot symbol of the atom itself, and then we remove a dot for each of the electron that is lost, or we add a dot for what is gained. So let's look at sodium and chlorine. Well, if I'm looking at the Lewis dot symbol of sodium, I go to sodium, and sodium has 1 dot because that's the valence electron. Now, another easy way to tell valence electrons is group number. Once again, ignoring this middle chunk here, if I label the periodic table group 1, 2, 3, 4, 5, 6, 7, and 8, not 13, because the 13 includes the middle chunk, but the 3 doesn't. So if you just write 3, 4, 5, 6, 7, and 8, they will guide you as to the valence electrons. Group 1 has 1 valence electron that it brings in. Group 2 brings 2, 3, group 3 brings 3, group 4, 4 electrons, and so on and so forth. So it's a nice, easy way to relate the group number to the number of valence electrons. Also, these group numbers, as we saw in the previous slide, relate the charge of the ion that is formed. So sodium, being group 1, has 1 valence electron, and therefore it will be represented by 1 dot. Chlorine, on the other hand, is over here, group 7. So it has 7 valence electrons, 2 dots on top, 2 on this side, 2 on the bottom, and 1 on the right-hand side. Now, these can be arranged any way you want, but you will only have 7 electrons around it. Now, sodium being group 1, it's easy for it to just lose that electron and become like neon, because it's closer to neon than it is to argon. And we said group 1 forms a +1 ion, meaning it's lost 1 electron. So it loses that dot, forming just a sodium plus. Chlorine, on the other hand, is right next to argon. So to get to argon, it just needs 1 more electron to have 8 around it. So it gains 1 electron. And so here we go. We will have a sodium plus with no dots, but we have a charge, right? The plus. Now for plus and -1, you can write a +1 here or a -1, or you can leave it out. It doesn't matter once again. With the other numbers, we have to specify how many. So +2, +3, or minus. But with +1 and -1, we don't necessarily have to write the number. It's implied in the sign, positive or negative sign. So sodium, since it loses 1 electron, that dot is gone and it just is replaced by that positive sign. This will be true for lithium, potassium, rubidium, cesium, francium. So all of them will have this configuration. And Lewis dot symbol. Chlorine, on the other hand, see, it now gained that extra electron, which is represented with a negative sign. That's the extra electron that is gained. So it has a full octet with a negative sign. This will be the same for all of those elements in the same group. So fluorine, once it gains 1 electron, instead of chlorine here, I could write fluorine minus with 8 electrons. Bromine minus with 8 electrons, etc., etc. Okay, it's your turn now. Let's see if you can write the Lewis dot symbol for the ion, which is formed by each of these elements: phosphorus, selenium, and strontium. Let's look at phosphorus first. I'm going to do that for you. So if you look in the little table that has the Lewis dot symbols for the atoms, this is the symbol for the atom of phosphorus. So it's got 2, 3, 4, 5 electrons. To get 8, which is the nearest noble gas, all it needs to do is gain 3 more. And here are the 3. Now these electrons that were single have been paired up, and I've gained 1, 2, 3 electrons. So I will put parentheses around phosphorus and a 3 minus, because I'm gaining them, I'm gaining negative charge, a 3 minus charge on the phosphorus. You can try selenium and strontium on your own.